Hello, everyone. My name is Laurent Tessier, and the purpose of this session is to talk about making sure data science really delivers value. And the question we have behind that is, why do many data science projects fail to deliver value? And in fact, why are they never put into production? So when we look at the process and the people which are playing with the process in a data science project, basically we can use the CRISP methodology, which is a methodology used by many data scientists and which is widely accepted among the community for data science projects. And basically, it turns around first, of course, business understanding, then data understanding, and you can see that there might be different paths on that. Data preparation, modeling, and again, different passes on that. Evaluation of the models, and then maybe going back to the business understanding and deploying the models. And that leads to, of course, making decisions. So the deployment is about providing value or KPIs that then can be used to take decisions. Well, when we look at who is involved in the different steps of the process, we have first the business understanding and the decision making, which is business to make. Then we have a big part, which is the data scientist part, which is the data understanding, data preparation, modeling, and evaluation. And finally, we have a part which is dedicated to IT, which is mostly about where the data is and providing this data, and also the deployment of the output of data science project to provide the decisions. But in the end, still, those projects usually fail or sometimes fail. So what can we improve in the process to make those projects successful? And from my experience and the different projects I've been working on, the real key to success is in the business understanding, because we have a clear objective for business, or they should be able to express a clear objective, which is to improve a process by including machine learning outputs into it. And these should be very precise because they are going to take decisions on those. Second is IT is responsible for providing those outputs to business so that they can actually make those decisions. And third, data scientists are there to basically massage the data to create the intelligence that will reside into the outputs and that will be used by business. If we want to take clear steps around how to improve that part of the process, is clear definition of the output required to improve the process. Second is data is the fuel, and we have to define upfront how it will flow, including how to integrate the machine learning components. And third, the data scientist should not dive into what is fun. And what is fun is data analysis. They should first make sure that everything has been designed upfront so that in the end, the results, the probability, the number, whatever it is, arrives safely to business so that they can take that decision. Or actually a machine could take the decision as well. Now, if we go to the process, that means that we want to remove part of the interactions between business understanding and data understanding, because it means that what we've done is basically define a real objective, and based on that objective, we don't have questions about which data should be used, and we don't have to do a back and forth passes to actually change the business understanding due to the data. It means also that there is a strong interaction between business understanding, deployment, and data, and that should be taken into account upfront. So examples of processes that could be improved by machine learning or data science projects are fraud, propensity to churn, for example, maintenance of assets, quality, etc., etc. When you look at those names, they are very vague. And what we need to do here as a team is really to define very clearly what is the objective of the data science project. And it goes to the point where we have to define the models, the outputs that will be provided. So for example, who among the high value customers is most likely to churn in the next 3 months? This is very precise, but because of this preciseness, a good decision can be made on the action to take to retain the customer, or what is the likelihood that an equipment would exceed a maximum temperature within a certain time, for example, 2 hours. And of course, that would mean that if we predict that this is likely to happen, we can do something about it to so take a decision to either stop this equipment or do something to refresh it or whatever is required in a business manner. So now, what about the next step? The next step is the data science part. And you know, one of the main challenges we have today is about data access and also the culture of IT of the data scientists. So I will start with that. We have many data scientists in the company that come just through from university, and there they learn Python and R. They learn how to do the algorithmic part, but they are not really aware of what an IT environment is. And that means that there might be some cases where doing things in SQL, so in a friendly IT environment, could be actually much better than doing them in Python and R, but they don't know about them. So they miss maybe simplifying the data flows that would make the process of giving the results easier. Because of that also, they just go to IT and they ask for a dump. Give me the data and I will do my magic and everything will be fine. Well, we all know it doesn't work like that because in the process, we have two phases. There is the training, the learning, and there is the deployment. And it's very likely that those two will be acting on different data, of course, and even maybe on data which is transformed differently. So rather than saying, I get my data, I get a big dump, CSV files, blah, 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 and I play and I do my magic, and then I go to IT and I say, oh, guys, here is the result. Use that. Do something to make it in production. You'd rather have them say, let's use as much as possible the existing IT environment, because that will smooth the path to the productionization. So how we will go from the learning and the experiments into the deployment and how the results will be integrated into applications which will serve business. So that's one of the main challenges we have, and we have to educate the data scientists quite a lot about that, because it's not in their culture. They've never learned about it. Okay, so for me, a good data science program today should include a very strong IT component, okay, where they learn about databases and SQL and how data flows into a company, how you replicate data and things like that. So then there is a point which is about the modeling itself. Okay, so in data science, you can be very creative in what algorithmics you want to use to address a problem. And there is often this question about what is the best algorithm? Oh, is it so important, actually? I'm not so sure. Because what is really important is to be able to deploy it, rather than say it's the best, it will give me the best lift, the best possible result. Well, maybe the best possible result is not the easiest to put in production, so maybe it's not the best one. And then we have to evaluate the quality of the model. So basically, we've created a nice data set. We've created lots of information from the data, and we try to extract that with the algorithmics. Okay, that's what the learning is all about. And what we want to do next is train and then see whether the algorithmics that we found, so the equation, basically, let's be clear about it, it's an equation, is providing a good enough result to be put in production and deliver value. Well, sometimes it doesn't, okay? And sometimes we don't have enough information in the data to provide this value. So that's where you have to maybe seek for other data, or sometimes it's just that there is not value in the data and you cannot address that problem with data science. And that happens, and that's perfectly fine. But let's now see how it all applies to the process that we were describing before. So, okay, yes. So you can see that now what we are saying is that, well, what we would like to do is between the data preparation, where we are massaging the data, and of course we model and we do the evaluation, that's where certainly we want to do some more data preparation, more transformation to try to extract more information from the data. And possibly, and that's what I just said, sometimes actually it means that there is not the right data or the data that has the value to predict what we want to predict. So then we also have to evaluate what new data we could bring in. So now let's go to the next step, which is the deployment. So now we are talking to IT. Okay, so the great job of massaging the data, finding the right equation has been done. And as a data scientist, I throw the ball to IT and I say, do your magic. You have to actually provide the results, the real good results that I created from all the work that I did into your IT environment, and then integrate that into the application that business will use. And here in basically we have two cases. We have the batch case and we have the real-time case. Okay, so I just gave two examples. So there is the churn. Obviously, this is batch, okay, because we are not in a time frame where it's required to actually provide those results every day or every minute, or there is no real action that would change the behavior of the high-value customer to churn in the next 3 months within the last minute. That's not there, okay? But you have other cases where it's not the case. So if I'm in a quality example and I'm on a chain of production, and at the end I'm producing whatever, something, and there is scrap. So some of my production goes to the bin. And of course, I'm losing money there. There is value in, I lose value in that scrap. So what we want is to be able to figure out whether the scrap level would increase to a certain limit within the next 5 minutes, for example. And here we are in a real-time case. But that real-time case has implications, because the way we need to transform the data is different. We cannot rely on the database where or the file systems where we did the training of the models to do the same thing and provide every minute, every second, every millisecond sometimes. Okay, not in my case, but it may happen. We cannot do that, those transformations, in the same way we did them batch when we trained the model. So we need to be able to actually create those transformations in a real-time environment, which means also that from scratch, when we are designing the way we will produce the results, we need to take into account that there will be a real-time component, and that real-time component means that within a certain amount of time, which is really small, well, there is real-time and real-time, of course, but really small, we have to get the data, transform it, apply the algorithmics we found, the equation, get the result, and push it to the application. So that is changing completely the cycle of deployment for the model. And if we go to what is it to deploy, in the end, it's business as usual for you. Okay, as IT guys, this is about ETLing, data orchestration, virtualization, if you can virtualize. It's about data transformation. It's about API call, batch processing, integration of code into real-time flows. So basically, it's not something that is difficult. It's something that you know how to do. The only thing is when it's done outside your environment, but with languages, tools which are not yours, taking all that and retrieving it into your environment and making it work might be actually more time consuming than doing the training of the models. Okay, I have examples at companies where actually the deployment was taking twice as much time as the data science project itself. Okay, and that meant that it was not working, basically. So now let's go to the next phase, which is the nature of data science also. Let's talk about shelf life, because data science has a shelf life. An equation that we find is based on data which was collected at a certain point of time with a certain history. And basically, the equation we find is an image of that. And if the data structure, the information in the data changes, then the results we get are leading to wrong decisions, because the result which is provided does not correspond to the data environment in which the equation was built. So we need to be able to control those equations, those models, to make sure that in the end, they deliver the expected results, so that the meaning of the results is not changing as time passes by. And that leads to other changes in the process. And basically what we need to do is, from the decision, measure whether we take decisions which have the same value. And if not, we have to redo the whole cycle again. And that is also where automation can be of interest, because this is something that would lead to easing that control over the overall process. And you know, that part is not fun. That part is not what you want to do as a data scientist, because basically you are just controlling the things and redoing them again and again to adapt to the ever-changing information that is in the data. Well, so here, and there have been attempts, and there are of course work done on that by the software vendors to actually remove those tasks from the hands of the data scientists, because they are not very interesting, and they basically not much added value to have them control. The value is more in creating the new models. So let's try and make sure that those things are automated as much as possible. And the last thing that may cause failure from a data science project is adoption. Because in the end, you've done all the work, okay, and you give results to the business. And of course, not all the people that are dealing with the process at stake were in the process of creating all these things. So maybe you have salespeople, you have marketing, whatever, and these guys, some of them don't believe, okay, or they've had bad experience previously, and they say, no, I don't want to use that. I know my business. I don't want to use your stuff there. Yeah. Okay. So again, by having them upfront in the process, it's easing the path, but not solving everything. So usually what we would recommend here is piloting with some of the people from business, so that they see the improvement and they can communicate to their peers the value of what the solution brings. And so basically is, by example, easing the adoption. And then there are a few other things, there are myths in what we do. We say, as someone, I have the machine learning on the data, but I still need to understand what it does. Well, do you understand how your car works? Not really, no, or some do, some don't. Or do you really understand how a plane works? Well, it's the same, it's a machine. So what you want is to get the results which are required to improve your business, and trust the machine that it found the right thing. And that's the work of the data scientist to validate that. And the second myth is about the machine will tell me what to do. Well, no. It finds the relationship between all these nice feature variables that we created, but it's very unlikely that it will tell you how to act on them. So with that, I would like to recap the overall presentation by saying, well, deploying a successful data science project means, first, it's a team. And it's a team on day zero. So it means that if you don't have business, IT, and data science working together to define really what the outputs for business will be, you will fail. It's thinking about how IT will get to provide the outputs from design, from the start, okay? It's trying as much as possible to make data science process IT friendly, okay? Because if we can have things which can be deployed directly in IT environment, it's much easier. It's surveying and controlling the what we are producing and reiterating if need be, and it's making sure that adoption and change management is dealt with. So in other words, and that's maybe a good thing to hear for you, it's an IT project, as usual, okay? We do the specs, we do everything up front. There is only one thing we don't know, which is the equation. But so it's an IT project where intelligence is added through machine learning. Thank you for your attention, and I'm ready for questions.